Alright guys, what we're going to start doing is looking at some proofs, but before we do that, we're going to learn a few new identities that we haven't learned yet, and we're going to revisit a few that we've already looked at. So to start off with, what we're going to look at are a few of the identities that we've already done, which are those reciprocal identities. So what you have, all this stuff I have copied on here is on your formula chart that you guys got in class. So I know that cotangent is equal to 1 over tangent, because cotangent is the reciprocal of tangent. What's not listed on there is also an equivalent way of writing that. I also could say that tangent is equal to 1 over cotangent. And I can use that same idea for both secant and cosecant. So even though it's not written on your chart, those are still true identities. Alright, but also we have that middle column there too. And that just comes from rearranging that first column. So if I were to rearrange this first function, if I were to multiply by tan on both sides, I would get that middle column. So all of these are different identities that you've already learned about, but just different ways of seeing them. Now the quotient identities we've also learned about. We really just talked about the first one, which is that tangent of x is equal to the sine of x over cosine of x. We talked about that when we did our unit circle stuff. But what we also have in here are a few other identities that we can use in these proofs later on. So the first one I want to talk about, though, is I just want to do a basic kind of a proof example where how we get this second half. So we're going to show how tangent of x is equivalent to secant over cosecant. So the way these work is you only work from one side of your equation at a time. So I'm only going to work from the tangent side. And what I'm going to do is I'm going to replace things on here to make it look like the right side. So if I look, tangent can be replaced with sine over cosine. Then I'm going to split this up so it's a little easier to see. Sine over cosine is the same as sine over 1 times 1 over cosine. And then if I look at my final answer, what I'm trying to get to, it has secants and cosecants. So if I look over there on the right, I know that sine of x is the same as 1 over cosecant. So I'm going to replace sine over x with 1 over cosecant of x. And I'm going to replace the 1 over cosine, from looking at my chart, 1 over cosine is the same as secant. And it's just regular secant, so it's secant over 1. And if I were to multiply those together, I would get secant over cosecant. So there were a few new identities on this paper, and what we're going to look at to start off with is just where these identities come from, how they came about, so we can kind of look at how they're not just random properties. So the first one is cosine squared plus sine squared is equal to 1. So I'm going to draw a little picture here that we're kind of used to seeing. I got a triangle with theta as my reference angle. My side to side is my x, my up and down is my y. I'm going to call the hypotenuse r, because it's kind of like the radius of your unit circle, or the radius for when you measure something in radians. And then I'm going to write a few things I can see off this triangle. First of all, I know with the Pythagorean theorem, x squared plus y squared is equal to r squared. Then I also can figure out, using my trig identities, sine of the theta in this picture is my opposite over my hypotenuse. My opposite is my y, and my hypotenuse is my r. And I can also find the cosine, which is my adjacent over my hypotenuse. So all I'm going to do now to make this look like that identity is I'm going to rearrange some things. So what I'm going to do is I'm going to divide everything by r squared. And x squared over r squared, that's the same as x over r, and that quantity is squared. So I've got y over r, and that whole thing is squared. And r squared over r squared is just 1. And now I can substitute what I have in these first two equations. Y over r can be replaced with sine theta, and x over r can be replaced with cosine theta. And remember, if we're squaring the whole quantity, I write that squared in the inside like that, because that means that we're squaring the sine of theta and not just the angle theta. So that's where the first identity comes from. Now the second identity we're going to get actually from the first one. Okay, so to get this 1 plus tangent squared, I'm going to take that Pythagorean identity I just did, and I'm going to divide both sides by cosine squared. So cosine squared divided by cosine squared gives me 1. Sine over cosine is tangent. And 1 over cosine, if we look at our reciprocals, 1 over cosine is secant squared. So that's where the second one comes from. Now if I want to do the third, okay, so that third one comes from, again, I start with that Pythagorean identity. So I'm going to start with cosine squared plus sine squared. And this time, instead of dividing by cosine squared, I'm going to divide by sine squared, just to kind of change this up a little bit. So cosine squared divided by sine squared is cotangent. Sine over sine is 1, and 1 over sine squared is cosecant squared. So that's where the third Pythagorean identity comes. Now you won't need to know how to prove these, this is just so you guys understand where these formulas come from. And we're going to use these to do a couple of these proofs. So what we're going to start off with is two basic transformations. So what we're trying to do here is we're trying to take this, we're trying to take the left side of the equation, and we're going to try to rewrite it so that it looks like the right side. So we're going to start with sine times cotangent, and we're going to try to make that look like cosine. So something's going to happen. That sine somehow is going to have to go away, so we really want that sine to cancel out. So if you look at your paper, cotangent can be replaced with a couple of different things. But the easiest thing to replace it with, for the sake of this question, if I replace cotangent x with cosine over sine, which comes from those quotient identities, if I were to multiply this together, what's going to happen now are my sines are going to cancel out, and all I'm going to be left with is cosine of x, which is what I'm trying to get to. So on these transformations, your work is really your answer to your question. So you need to really show the work on these, because that's really what we're doing. Alright, so we're going to try another one. We're going to do this one down here, that's sine x times secant x times cotangent x. And again, there are multiple ways that you can actually solve these. It'll actually still work. Some are shorter than others, some are the exact same number of steps. It's just a matter of what makes the most sense to you. So what I'm going to do here is I'm going to keep sine of x as sine of x, but I'm going to replace secant with 1 over cosine, using those reciprocals, and I'm going to replace cotangent with cosine over sine, using those quotient identities. And now, again, if I were to multiply this all together, sines cancel out, cosines cancel out, all I'm left with is 1 over 1, which is the one I'm trying to get to. But again, there are multiple ways you could do this. So another way I could have done this, I could have replaced sine with 1 over cosecant. I could have kept secant by itself, and I could have replaced cotangent with cosecant over secant. That's also on that quotient identity page. And if I did that, secants cancel, cosecants cancel, and all I'm left with is 1. So there are multiple ways you can do these correctly still. Alright, so now we're going to move on to a little bit of a tougher one. Okay, so in order to make my left look like my right, there's a couple things I'm going to need to do here. What will probably be your easiest first step, and what I'm going to do first, is I'm going to go ahead and FOIL this out. So in order to multiply this, you have to remember that means cosine minus secant times cosine minus secant. So I'm actually going to FOIL this, so everything gets multiplied by everything. So cosine times cosine is cosine squared. Then I've got cosine times that negative secant. It's going to give me a negative cosine x secant x. Then I get another one. And remember, you can write these in any order if you're multiplying. So negative secant times cosine is the same as negative cosine times secant. So I'm going to go ahead and write it that same way. And then my last one is that secant times secant, which gives me a positive secant squared x. So now I'm going to try to make this look like my final answer. Okay, so if you look back on your identities paper, one thing that's written on the identities paper that's going to make this a little easier is it tells me that secant squared is equivalent to 1 plus tangent squared. So I can replace secant squared with 1 plus tangent squared. What I also have on that identities paper is that cosine x secant x is equal to just 1, and that's under those reciprocal properties. So I can replace both of those with just 1. So then the last one I need to change is that cosine squared x. Now, I don't have anything that says cosine squared by itself, but what I do have, I do know that sine squared plus cosine squared is equal to 1. And what I can do with these Pythagorean identities is I can move them around, and I can move things around algebraically to see what I'm trying to actually get to. So I can get cosine squared by itself on this question. All I need to do is subtract sine squared from both sides. It doesn't change the equation, but what it tells me then is that cosine squared is equal to 1 minus sine squared. So what I'm going to do is replace that cosine squared with 1 minus sine squared. So now I have 1 minus sine squared minus 1 minus 1 plus 1 plus tangent squared. And I'm just going to start combining some like terms. The 1 and the negative 1 are going to go away. The negative 1 and the positive 1 are going to cancel out. So all I'm left with is negative sine squared plus tangent squared. And I'm just going to rewrite that in the order that my answer has. And there's my final answer. Alright, so the next one we're going to look at uses a similar idea. Okay, again, you always want to look at what you're starting with and what you're trying to get to. So my final answer that I'm trying to get to has a sine squared in it. So I don't really want to get rid of the sine squared that I have in my original question because that's in my final answer. But what I want to try and change is that cosine squared. And again, what we just did in that last question, sine squared plus cosine squared is equal to 1. So that means that cosine squared is equal to 1 minus sine squared. So I'm going to replace that cosine squared with 1 minus sine squared. And then I still have the original minus sine squared. And now it's just simply a matter of combining like terms. So all I have to do after this, combine those two sine squares together, and I get my final answer that I'm looking for. 1 minus 2 sine squared. Alright, the last one's actually straight off of our homework, and it's going to be number 7. So I have the tangent of x plus the cotangent of x, and I'm trying to turn that into cosecant times secant. Again, there are multiple ways you can do this, but if you're not sure where to go, sometimes a really easy start is to put everything in terms of sines and cosines. So what I'm going to do here is I'm going to replace tangent of x with sine x over cosine x. And I'm going to replace cotangent with cosine over sine. Now if you look at your final answer here does not actually have a plus sign in it. So somehow I'm going to have to combine these two things together. So the only way I'm going to be able to do that is if I get a common denominator. So I'm going to get a common denominator by multiplying the left fraction by sine x over sine x. So it's not changing the fraction, it's just multiplying it by 1. But again, I'm getting a common denominator. And on the right, my common denominator is going to be cosine over cosine. So now when I combine these together, my left fraction becomes sine squared over sine cosine, and my right fraction becomes cosine squared over sine cosine. So now that I have a common denominator, I can combine the numerators together, and I keep the same denominator. So this becomes sine squared plus cosine squared, and it's over that same denominator of sine x cosine x. And again, I'm trying to look at what my final answer has. So my final answer has cosecants and secants. I don't have any squareds, no sine squareds or cosine squareds. And if you look at your identities chart with those Pythagorean identities, sine squared plus cosine squared is the same thing as 1. So now I have 1 over sine x, 1 over sine x cosine x. So what I'm going to do to make this a little easier to see, you don't need to show this step, but again, it might make more sense if you don't see it right now. 1 over sine cosine, that's the same thing as 1 over sine x times 1 over cosine x. And then again, using those reciprocal identities, I know 1 over sine x is cosecant x, and I know 1 over cosine x is secant x, which is what I'm trying to transform this to. Alright, so after this we're going to move on and we're going to do some proofs later on this week, but this is it for the start, and these are just transformations using those new properties.